Here is a question about what ultimately leads onto winches and how the friction around the winch means that there's this difference in force between P and Q. Winches are used on boats and to hold mooring lines from boats onto the shore. So let's start with this problem straight away. State the conditions which apply for a body to remain in equilibrium under the action of a set of coplanar forces. Well, the forces in each component must be equal to each other in order for it to remain in equilibrium. And that's exactly what's needed in the second part, which looks at the small change in angle of the tension of this piece of rope. This is a completely smooth cylinder, and it has a small change in angle delta theta. So you're asking to find the relationship between how a delta n t and delta theta are related. So all we have to do is take into account this idea at the top, which means that the component of forces are equal. So let's first of all work out what the vertical component of that force there will be, and then we can relate it to delta n. Well, if we imagine there we've got half theta, then that angle in there should be delta theta over 2. I hope you can see that. And also that makes intuitive sense, because as that bit straightens up to the vertical, this is going to straighten up to the horizontal. Okay, so it's simply a t sine delta theta over 2 gives us this component from this side, but also we have another one from that side, so we need to multiply that by 2. But we also know that sine of theta is approximately theta for small angles. So therefore, let's just jump onto this side. We have t sine delta theta over 2 times 2, which gives us t delta theta over 2 times 2, which gives us t delta theta. And of course, if that's in the vertical direction, downwards, therefore, we must say that delta n is t delta theta. There is our identity. Good. Now, looking at the second part, we have a rough cylinder, and we have a force P and Q, and it says right at the bottom here, discuss whether the inequality in the magnitudes of P and Q, how to account for them, because it says here that P can be very much less than Q. So if P were very much less than Q, then you'd imagine how can this be in equilibrium? Well, the key is there, it's a rough cylinder. So therefore Q is going to equal P plus the force due to friction.